Okay, not that tough. If anybody has to slap their face, please do it now. It gets very distracting. Now back to the science presentation. Have you ever wondered why Pop and Mentos react? Or maybe how other candy might react with Pop? But don't get out of your seats because we glued them before the show. Oh, what we didn't? Okay, somebody's fired. Never mind that. Now back to the presentation. First up is why Mentos react the best. So the structure of Mentos allows carbon dioxide bubbles to form rapidly. When this happens fast enough, you get a nice Coke fountain. What can be better? Another name for carbon dioxide is CO2. If you don't know how it's formed, listen up. When two atoms of oxygen meet one more carbon atom, CO2 is formed. So think of it this way: the pop is CO2, and the Mentos is oxygen. Put the oxygen inside the CO2, and the CO2 turns into a gas and comes out the bottle. My topic has like no research and I'll find it all out today. Soon we'll drop some Mentos in these pop bottles. I'll also test rockets, gummies, and Jolly Ranchers. This is what I'm hoping most of my experiments will turn out like. And now, the moment of truth. Pop and Mentos. If you look closely at the bottle, you'll see CO2 bubbles forming, but this happens really fast. Okay, there's nothing. Guys, remember it's covered. I don't want that covered. Okay. Whoa. See you, man. Shh. Here goes nothing. Take cover. Now for the next test. Jolly Ranchers and Pop.
No. Are you scared? Hard candy?
Test won't work.
No, Gavin. Gavin! Why not?
Probably won't work, but...
Yay!
What?
It worked a
Mini fountain. It worked just a little bit. That happened because there are no nucleation sites on this. And nucleation sites makes the CO2 bubbles like on the Mentos. Now for test 3. Rockets and Pop. These are a little bit carbonated, so they might just work. With the whole package. Just a couple.
Oh, it looks like a root beer fountain.
Now for the last test, which I really don't think will work. Gummies and Pop. I don't think
No, I have really good hands, man.
Yeah, you have really good hands.
A fan.
It's okay, Carter.
Okay.
Yay!
Hopefully you can see there are no CO2 bubbles forming. That's too bad. Well, that's it. And I'm starving. Anybody have a sandwich in their pocket?
No.
Okay, never
I got
mind.
milk.
Oh, here's a quick clip about Mentos and Pop. Say that 10 times fast.
Sound funky?
The Midwesters are going to have a blast. The most common theory about what's going on in this reaction between the candy and the soda is what's called nucleation. Basically, the idea is that the surface of the candy is covered with microscopic pits and lots of more surface area than you can actually see. And each little pit, each little corner provides what's called a nucleation site, or a place where a carbon dioxide bubble can form and escape.
Look at a Mentos close up, and it's like the surface of the moon. And that might be the candy key. Drop one in cola, and every tiny crater provides a site where a CO2 molecule can change to gas. Because Mentos are so pitted, the theory is that millions of CO2 bubbles are formed in a very short space of time. And because the candy sinks and this rapid release of gas happens at the bottom of the cola, you get that famous fountain. To test this nucleation theory, they're going to start with a control. One regular mint Mentos dropped in soda water. And sure enough, it gets the bubbly party started. Now, to do a comparison.
These two candies are made by the same manufacturer, and as far as I'm aware, even using the same process. But the colored version of this actually has a glazing over it. It's a wax coating or a sealer that inhibits the nucleation process that the other one achieves quite readily.
The shiniest surface should lower the nucleation sites, meaning less of an immediate eruption.
That's not doing anything more than the wall of the plastic bottle itself.
Sure enough, with the smooth Mentos, there ain't no whiz with the fizz. The Mythbusters can say they finally cracked the case of the candy and cola cascade.
Yeah. That's it. Hope you enjoyed and learned at least something new about this experiment. Any questions?